Right, so today we're going to be solving quadratic inequalities. So we know that inequalities are just variations of equations, but they can have more than one value. So we're going to be solving this in the same way we would solve a quadratic equation, and then we'll see a small difference at the end. So first one. The first thing we always check when the number in front of the x squared is 1 is what are the factors, or are there any factors of the third number that add to give you the second number. We should be able to tell there's only one set of factors for 3, which is 1 and 3, and in this case both these add up to give us 4. So our brackets are going to be x plus 1 and x plus 3. Now if we were solving this like a normal equation, the solutions we would get are x equal to minus 1 or x equals to minus 3. So let's sketch the graph to help us here. Now remember, with a quadratic graph, we can tell what shape it is based on the number in front of the x squared. Since it's positive, we know it's going to be a U-shaped graph. Then, where is it going to cross the x-axis? At these solutions here. So 1 at minus 1, and then once at minus 3, and then its intercept is at positive 3. So it's going to look something like that. Now what you need to determine is what the range of values. The way we check this, we go back to the original equation. Now this x squared plus 4x plus 3, this is an equation for y. So we could have y equals x squared plus 4x plus 3, which we sometimes see. So what I'm going to do in the inequality, I'm going to replace my equation here with a y. That tells me I'm looking for the values when y is greater than 0. So we're looking at the y-axis. So when is my graph greater than 0? So that's everything in the top region. What I can see, so let's use a different color for this. It's everything that goes along this blue line here, and then this blue line here. And what you have to realize is both those blue lines, the first one's going more towards the right as it gets bigger, and the other one's going more towards the left. So it's getting bigger than minus 1 and smaller than minus 3. So x is greater than minus 1 and x is less than minus 3. And those are your two solutions for that quadratic inequality. Let's look at a different example where the inequality is on the other side. So once again for this one, since we have a 1 in front of the x squared, we're going to try and find the factors of 35. So we've got 1 and 35, not 3, 4, 5, and 7, and that's it. But we also realize, since this is a negative number, we also take the negative factors. So minus 1 and minus 35, minus 5 and minus 7. If we want to get to minus 12, we realize these two will give me it. So my brackets are going to be x minus 5, x minus 7. So my solution for the equation is x equal to 5 or x equal to 7. And then once again we'll draw it just to see. You always want to make sure you draw the sketch so that you show the examiner how you know what part of the graph to look for. So we know it's going to cross at 5 and 7. It's positive because it's a positive x squared, and the intercept is at plus 35. Something like that. Now once again, what you want to do, you want to determine if you're going above or below the y-axis. The way you check here, once again you want to replace the equation with a y. So y is less than 0. Now the part of your graph where y is less than 0 is the bottom half. And what you realize in this case, it's the range here between 5 and 7. So the way you'd write it as an inequality, your answer is going to be 5 less than x less than 7. So what you realize here, whenever you have a less than 0, it's going to be a range between your two solutions, and whenever you have a greater than 0, it's going to be less than this one and greater than that one. Let's go into some other variations. Now this time we've got one where we don't have a 0. It says solve x squared is less than or equal to 100. Now you should always know when you're solving an equation, you can only solve it once you have a 0 on one side. The way I'd solve that is by taking this 100 to the other side to be left with 0. So let me minus 100 from both sides. I'm left here with x squared minus 100 is less than or equal to 0. Now we have an equation we can solve. Now you should all realize what sort of quadratic this is. We have a square and a square number, so it's going to be a difference of two squares. So our brackets are going to be x plus 10, x minus 10. So our solutions are going to be x is equal to minus 10 or x is equal to 10. So we'll draw the graph. So we're crossing at 10, minus 10 and minus 100. Let's just do 10, minus 10 and minus 100. Now once again, you're going to replace this with y. So you're looking for the values when y is less than or equal to 0. So that's the bottom half of the graph. Once again, as we saw in the previous question, it's going to be the range between your solutions. Your answer is going to be minus 10. Remember the equal sign in the inequality, in this case, less than x less than or equal to 10. And that's your final answer there. Now let's try one where the number in front of the x squared is bigger than 1. So we're going to have to use some of our other factorizing skills. There are two ways to do this. Either you can use the quadratic formula, or use the expanded factorizing where you times the first number by the last number. So let's try that first. 6 times minus 10 is equal to minus 60. So we're finding the factors of minus 60. That will give me 11. We've got minus 1 and 60, minus 2 and 30, minus 3 and 20, minus 4 and 15. This one works here. So we're going to rewrite this as 6x squared minus 4x plus 15x minus 10 is less than 0. So we always split it so we can factorize each half. I can take a 2x out and be left with 3x minus 2. I know I'm going to have the same bracket on this side. So in order to get that 3x minus 2, I must have taken out a positive 5. So one of my brackets is 3x minus 2, and then the other bracket is 2x plus 5. So once again, to solve both of these brackets, you set them equal to 0. So 3x minus 2 is equal to 0, x is going to be 2/3. And if 2x plus 5 is equal to 0, x is going to be minus 5 over 2. So let's quickly sketch our graph. So we cross at 2/3, minus 5 over 2, and the intercept is minus 10. And it's probably going to be more on the minus side since it's the biggest number. So it's going to be, the bottom's going to go more on this side, like that. So that's minus 5 over 2, 2 over 3. And you always want to label these values as well. So once again, we want to replace the equation of y to determine where we're looking at. So we're looking for the value of y is less than 0, which we should realize is the range between our values here. So it's the range between minus 5 over 2 is less than x less than 2 over 3. You could have also solved this using the quadratic formula. You would have got those two solutions, and then these final steps would have been the same. We'll do one final example here. So once again, in order to solve the equation, we know we have to get it equal to 0. But the x squared is on the other side this time. So you want to take everything onto the other side to make sure the x squared remains positive. So first thing I'm going to do, we're going to take away that 6x. So I'm left with a 27 here, and x squared minus 6x. And finally you want to take away that 27. Now what you want to be careful with, because I'm going to rewrite this with the x squared at the beginning, you want to make sure you get the inequality the right way around. We know it was a less than when it was next to the x squared, so it's going to be a less than 0. Now we try and solve it. Are there any factors of minus 27 that give me minus 6? Let's check. So I've got minus 1 and 27, minus 3 and 9. That doesn't work. So let's try the other ones. 1 and minus 27, and then 3 and minus 9. This one works. So I'm going to rewrite it. I'm going to put it into brackets. So once again, it's going to be x plus 3 and then x minus 9. So your solutions are x equal to minus 3 or x is equal to 9. So then let's sketch the graph. So once again, you know it's positive, since it's a positive x squared, it crosses at minus 3 and then 9, so the bottom is going to be somewhere around here, and the intercept is minus 27. So we're going to go down like this, and then up like that. 9 minus 3. Once again, we're trying to find what part of the graph we're interested in for the range of values. Well, we know we're going to replace this equation for y, so it becomes y is less than 0. Y is less than 0 is the range here to here. So we know it's going to be minus 3 is less than x less than 9. An important final point to note, if it was y greater than 0, if we had a greater than 0 here, our solutions would be x would be bigger than 9 and less than minus 3, because we're looking at those separate range of values. So just a quick recap, whenever there's a greater than 0, you're always going to have two separate inequalities, one greater than for the right hand side and a less than for the left hand side, and whenever you have a less than 0, it's going to be the range of values.